Alright, let's take a look at wildcard masks for a minute. So I find the easiest way to cover this is to talk about what you already know. So for example, if I gave you a 192.168.30.z being anywhere between 0 and 255, you know the default mask is 255, 255, 255.0. And you know what that really means is you put a divider line after the last 255. The stuff on the left is the network, the stuff on the right is the host. And think about that. What that means is if I give you another IP address such as 192.168.30.7 and another one of 192.168.30.50, you know those guys are on the same network because for each 255, it means that the numbers have to match exactly. In other words, 192 has to be the same as 192 down here. 168 has to be the same as 168 here. Nice 8. 30 has to be the same here. But when you see a .0, it means it could be anything in the range. And we talk about clients, we're talking about between 1 and 254, don't we? So whenever you see a 255, you know it has to match exactly. When you see a 0, it means it's the whole range. So, in we talk about wildcards, it's actually the opposite. All you got to do to find the wildcard is each column needs to add up to 255. So for example, 255 plus what equals 255? Well, that's 0. 255 plus what equals 255? 0. 255 plus what equals 0? 255. 0. 0 plus what equals 255? The answer is 255. That's why this is exactly the same thing as this, just written in a different format. Let's take a look at another example. What if I gave you the subnet mask of 255, 255, 255.224? Remember, to get the wildcard mask, each column must equal to 0. Must equal to 255. So let's do it. 255 plus what equals 255? Well, that's a 0. 255 plus what equals 255? That's a 0. 255 plus what equals 255? That's a 0, right? If you add them up, 224 plus what equals 55? 255. Well, a 31, right? So that would equal 255. That would equal 255. 255. 255. So what that's saying is this wildcard mask here is equivalent to this, because when you add them up, they always equal 255. So let's take a look at an example of this. I'm going to go ahead and start a new screen, like so. And I wrote down a couple examples here. That's all I did. Oh, there it is. Okay, so let's take a look at some of these. Let's say, for example, you were given 192.168.1.3 with the equivalent of the wildcard mask of all zeros. Well, let's put it back in the 255 format so we can understand what's going on here. 0 plus what is 255? Well, it's a 255. So it's this. This is the subnet mask equivalent. So what that means is each column has to match exactly. So does it make sense that we could say something like deny, or did I do permit? Yeah, deny. Access list 1, deny 192.168.1.3.0.0.0.0, because that equals this in subnet mask language. Must be a perfect match. So the first thing on the access list it goes is the IP address this? Well, if it's not, it goes to the next line. This one says 192.168. Let me check my time. 192.168, 2.0. And the mask there was wildcard mask, okay. 0.0.0.255. Now, let's convert it. Let's put it back in the 255 format. It's the opposites, right? 255.255.255.0. Meaning, as long as the first 3 octets here match, it could be anything in this range. Now, one more example. We're a little bit laggy here. Yeah, that's a good one. Right at the bottom here. 192.168.2.16. So let's say we're seeing a permit of 192.168.2.16. And the wildcard mask is 0.0.0. Was it 15? No. Sometimes I want to plug my own numbers in here. Yeah, 15. So the first thing I'm going to do for myself is convert this back to 255 format so it makes sense to me. 255, right? 255. 255. Dot. 15 plus 1 equals 255. That's a 240. That's a slash 28. That's a delimiter of 16. Right? Increment of 16, range of 16, whatever you want to call it. So we know to hit that. We know to solve those. 192.168, 16, add the delimiter, right? We just keep adding the delimiter. 31, up 1, down 1. So that means I can either allow or deny that range. All right, hope that helped out for wildcard masks. I'll see you later.